In this example, we are going to try to find the volume of a solid generated by rotating around the x-axis, bounded by this information. So let's create ourselves a visual. And at the end of this is for us to find the volume, we are talking about making all these little cylinders, and we need a formula that looks like this. Area of the base times the height. So let's draw ourselves a picture. And we have some sort of an exponential decay. This would have a y-intercept of 1, and then we'd have some sort of a decay happening, leveling off. We are bounded by y equaling 0, which is the x-axis, x equaling 0, which is the y-axis. So we're just talking first quadrant. And this line of x equals the natural log of 4. So the natural log of 4 is somewhere down here. And so this is the shape that we're trying to rotate around the x-axis. All right, so that's what we got going on. So it's not a geometric shape. In a previous example, we had a cone that was created, and so we actually could take a geometry way of looking at it. But we don't get something like that. So we're going to get some sort of a funnel-ish looking thing. So for our volume, we are going to be doing this. And so it's going to be pi. Our radius is going to be our heights, and our heights are dictated by this equation. So e to the negative x. So it'd be e to the negative x squared. And then our heights are always our thicknesses of these cylinders, which is dx. And we're going from 0 to the natural log of 4. All right, so there's our setup. Let's do some math on it. Let me clean this up a little bit. That I always am going to pull the pi out. 0 natural log of 4. If I multiply this together, this is going to be e to the negative 2x dx. And this has a u substitution field to it. So let me do a little side work here. I'm going to let my u equal negative 2x. du is going to equal negative 2 dx. Let's divide that over. Negative 1/2 du equals dx. So if I rewrite this in terms of u, I'm looking at a negative 1/2 pi. The negative 1/2 would come in front. I'm going to not mess with my bounds at all. I'm going to leave it alone because I'll put it back into terms of x here in a second. And then this is going to be now e to the u du. All right, so I do that so I can do my antiderivative much, much nicer. The antiderivative of e to the u is e to the u. And then let's pull our terms of x's back in. So we have a negative 1/2 pi e. Instead of u, let's put the negative 2x back in. And then we're going to go from back to our 0 to natural log of 4. All right, so only thing left to do is just plug some stuff in. Let's figure out what our volume is. So we have a negative 1/2 pi. We can kind of hold off and plug that in at the end, or we'll multiply it in. So we have, I made an X on that. And so let's plug in our natural log of 4. So we're looking at e to the negative 2 natural log of 4, right? And then minus e to the natural, or e to the negative 2 times 0. All right, so negative 1/2 pi. All right, so on this, we have some manipulation we can do. I need to take that negative 2 and I'm going to pull it back as an exponent, right? Remember that things in front of natural logs were originally exponents. So I'm going to rewrite that as an e to the natural log of 4 to the negative 2 minus, this is just going to be a 1. And the reason I do that is because now e to the natural log, those bases match, my value just becomes 4 to the negative 2. So I'm looking at a negative 1/2 pi times 4 to the negative 2 that I'm going to probably have to mess with. And so that is a negative 1/2 pi. This is 4 to the negative 2 is we're still squaring the 4, except it moves it to the denominator. So 1/16 And then I'm going to be subtracting 1 from that. So I'm going to be subtracting 16/16, which is -1/2 pi times -15/16. And if I put that together, I'm going to get a negative times a negative is going to cancel, which is good because I should have a volume that's positive. And so it's a 15 pi over 32 is my volume. All right. So that was finding a volume rotating around the x-axis of some sort of an exponential decay type of a problem.